Hello, dear students. Due to the different problems that you had in chapter number 2, I decided to make this uh, lecture. Let's go over the chapter number 2, measurements and calculations. This chapter is very important to understand how to make calculations in chemistry. So let's begin by what is a measurement? A measurement is a quantitative observation. Then you need to use a number, but also you have to use units. This is very important because sometimes a student used to put a number and no units, and we don't know what we are talking about. In other classes, I used to say, well, what are you talking about? 23 bananas or 23 centimeters? So it's very important, the unit. Another important thing is how to express very large or very small numbers. For that, you have to use the unit multiplied by a, a 10 and an exponent. That's what we call scientific notation. For example, this number 93 million is very large. What you do? Well, you suppose that you have a dot here, and you begin moving the dot 1, 2, 3, 4, 5, 6, 7 times. Then you write 9.3, and then you multiply by 10 million. But you will convert this number into an exponent. If you have 1, 2, 3, 6, 7 zeros, then you use the exponent 7, and it is positive because you are moving your dot to the left. Every time you move your dot to the left, the exponent will be positive. Positive exponent, okay? In the case that your number is very small, then you move your dot to the right. And for example, here you are, you move the dot 1 time, 2 times. Always you have one number and then the dot. This number is different from 0, different from 0. And then you write the whole numbers after the 6. And you multiply by 10. As you move the dot 2 places to the right, then the exponent will be negative. How many times? -2. This is what we call scientific notation to express very small numbers or very large numbers. For example, which of the following is correct or correctly expresses 7,882? Well, you're supposed to have a dot into here, yes? And you move the dot 1 time, 2 times, 3 times in such a way that you will get 7.882. The dot is now here. and then you multiply by 10. If you move to the left 3 times, your exponent will be positive 3. Then you put here a 3, you don't need to put the plus sign. This is a number that better expresses this number. So this is the answer. Let's see in this case. Oh, this is a very small number. Then you move the dot 1, 2, 3, 4, 5 times. Then you will get 4.96 multiplied by 10. As you move the dot 1, 2, 3, 4, 5 times to the left, then the exponent will be negative 5. That's why you have this answer as the best that expresses this small number. Well, what is a system of measurement? First of all, is a unit, the scale or a standard being used to represent the results of a measurement. Scientists require common units to measure quantities such as mass, length, time, and temperature. In United States, we use the English system, but in science and in the rest of the world, we use the metric system. Right now, we are using the international system that comes from the metric system. It is the metric system uses the kilogram, the meter, the second, the Kelvin, the ampere, and the mole as fundamental units of mass, length, time, temperature, electric current, and amount of substance. For amount of substance, it is very important for chemistry. We are going to speak about mole later on. The ampere is mostly used in physics, but the Kelvin, second, meter, and kilogram are used every day in chemistry. The prefixes in the metric systems will change the size of the unit. For example, a million uses the symbol M, capital letter, that represents a mega. 1,000 represents the prefix K, that represents a kilo. And so for the deci, the centi, the milli, the micro, and the nano. Here you have the meaning of this symbol, and here is how it is expressed in power of 10 for scientific notation. For example, a kilometer is 1,000 meter or 10 to the third meter. A decimeter is 0.1 meter or 10 to the minus 1 meter. And so on, you have for every unit. This is the symbol for micrometer, and this is the symbol for nanometer. The cells can be measured in micrometer. But nowadays we have what we call the nanotechnology, where we use nanoparticles. The nanoparticles can be measured in nanometers. That is 10 to negative 9 meter. A micrometer is 10 to minus 6 meter, and so on. What is volume? Volume is the space occupied by a substance. In the international system, we use the cubic meter. 1 milliliter is equivalent, not the same, but equivalent to 1 cube centimeter. And 1 liter is equivalent to 1 cube decimeter. For mass, we use the kilogram. This is the way we measure matter. 1 kilogram is equal to 2.2046 pounds. And 1 pound is equal to 453.59 grams. What is a gallon? Well, a gallon is 4 liters. Then this statement is correct. And 200 pounds is 90 kilograms. This is correctly represented, but a basketball is 7 meters tall. What's that? Here we have only one unit. A basketball is not a unit. A nickel is not a unit. So these two are not correctly expressed. What is the uncertain of a measurement? Well, a digit that must be estimated is called the uncertain of a measurement. All the measurements has certain degree of uncertainty. For example, if you are measuring this nail and you're using this rule, you can see that the length is between 2.8 and 2.9 centimeter. What is certain for you? That the length is 2.8 centimeters. But is 2.8 sharp? No, it's something else. Then you have to estimate and then you choose for the third digit 5. Then you say that your measurement is 2.85. That is a number between 2.8 that is certain and 2.9. Then the 5, the digit 5 is uncertain. Non-zero integers always count as significant figures. What are significant figures? Are the figures in a number that are certain. For example, the zeros, if they are leading zeros, they never count as significant figure. For example, this 0 to the left never are considered significant figure. This number has only two significant figures, the 4 and the 8. If there is a digit that is between two integers, it is considered a significant figure. And if you have a number like this, where you have a 0 and you don't have a decimal point anywhere, you say that this 0 is not significant. It doesn't mean that this number is 15, it's 150. But you don't consider the 0 a significant figure. It's a different concept. But if you have a decimal point and you have trailing zeros, you consider this 0 as significant because of the decimal point. What is an exact number? Are numbers that you obtain by counting 9 pencils, 10 pencils, 11 pencils. But also you consider an exact number when you are using an equivalent between two units. 1 inch is exactly 2.54 centimeters. And these are exact numbers. Well, we have spoken about the scientific notation, how to move the dot to the right or to the left when the number is very small or very large. And then you multiply by 10 and an exponent that represents the number of places that you move to the right or to the left. The sign positive is for very large numbers, and the symbol negative is for very small number. And the number that you use here represent the number of places you move the dot to get a number like this, with only one number different from 0 and then the decimal point. Then, what are the rules for rounding up? If you need to round to two significant figures, you have to observe the number that continue these two significant figures. It is a 4. Oh, it's lower than 5. Then this number is rounding to 5.6. You remove the 4. But if the number is 5.68 and you have to round to two significant figures, you have that the first number that you have to skip is higher than 5. Then you round up and your number is around 5.7. In a series of calculations, carry the extra digits through the final result, and then you round off at the end. What you can do, for example, if you're multiplying 32 by 3, you have here that this number have two significant figures, and this has only one significant figure. Then the result must have one significant figures corresponding to the number with less significant figures. The answer for this will be 36. But this number has two significant figures and you had to report only one, then you round up to the next number closer to this with only one significant figure. Of course, it is 40, and this is the answer for this multiplication in chemistry. Because this zero is not considered a significant figure, it's a trailing zero. And this number has only one significant figure, and is the closer to this with only one significant figure. Remember, when you multiply, you had to report the number of significant figures of the number with less significant figures. For example, in this mathematical operation, you multiply these two numbers and you say, oh, the number with least significant figure is this, two significant figures. Then I had to report until here. Then you say the first number I have to skip is higher than 5. I have to round off. And then you add 1 here, and this is the answer. With only two significant figures, corresponding with the number with least significant figures. This corresponds to multiplication and also for division, but not for addition and subtraction. The correct way to do an analysis of addition or subtraction is doing the operation this way. Then you say, you make a line through the number with less significant figures. And you say, I have to report only until here. As this number is 5, then you round up, and this will be the answer with 4 significant figures. Okay, dimension analysis. Dimension analysis. This is a method that is used in chemistry to do calculations. Dimensional analysis always use factors. What is a factor? Oh, you know that 1 feet is 12 inches. Then you can say, you can make factors saying that 1 feet is 12 inches or 12 inches is 1 foot, sorry. Which one you will choose? Okay, I will tell you right now. For example, if the given number is 6.8 feet and you need the answer in inches, then you need to use a conversion factor where you can cancel feet with feet. And you get here inches. Then which one you are going to choose? 12 inches is 1 foot. In such a way that you cancel foot with foot and you get inches. The answer in this case is a multiplication of this times this divided by this number. Okay. Let's see this example. What data would you need to estimate the money you would spend on gasoline to drive your car from New York to Los Angeles? For example, you know that the average gas mileage is 25 miles per gallon, and that the average cost of gasoline is $3.25 per gallon. So you have two conversion factors. the given number is the distance, and you need money. How can you go from miles to money? Well, first you have to convert miles into gallon. And later you cancel gallon with gallon using this conversion factor, and you get money. That is what you need in your answer. Then you multiply this by this and by this, and you divide by this and then by this. This is the answer. You have 3 units of measurement for temperature: Fahrenheit, Celsius, and Kelvin. And there is an equivalence between these 3 units of measurements for temperature. The boiling point of water happens at 212 Fahrenheit, 100 Celsius, or 373 Kelvin. Same thing for the freezing point of water is at 32 Fahrenheit, 0 Fahrenheit Celsius, and 273 Kelvin. So you can use these conversion equations to go from Kelvin to Celsius, or from Celsius to Kelvin, or from centigrade to Fahrenheit, or the opposite. For example, in this exercise has a wrong answer in your presentation. This is not the answer. The answer is this. Why? Because the given number is Fahrenheit. You had to go first from Fahrenheit to Celsius, and then from Celsius to Kelvin using these 2 equations. And the answer is this one. This is the correct answer. Then you have here an exercise. You can take a look at this later, and you can answer this. Let's go to density. Density is a relationship between the mass of a body and the volume that it occupies. Generally is in grams per centimeter cube or grams per milliliter. Remember that 1 cube centimeter is equivalent to 1 milliliter. The method that is used to measure the density of a solid is the water displacement. Then, for example, when this girl goes into this pool, the level of water raises. The difference between the level with and without the girl inside is the volume of her body. And if you weight her, you can get the mass in grams, for example, and then you calculate the volume in milliliters. For example, this is the mass, this is the volume of a mineral, and then you say the density is 7.57 grams per centimeter. Look at this, you reported 3 significant figures because in the division you have a number with 3 significant figures and 3 significant figures. That's why you report the answer with 3 significant figures. Okay, here you have another example. And you can go and look at these exercises in the PowerPoint of the week number 2. You can look for the answers. Well, that's all what I wanted. If you have any doubt, you can ask me for a meeting, and I will stay with you as soon as possible.